Hello, everyone. I wanted to thank you for joining. We have a great turnout and some fantastic information to discuss with you today. We'll jump into the first portion of the presentation in just a minute. First, I wanted to do a quick introduction of myself, Mike McKenna, Director of Business Development at Ingenuity Systems, and how we are involved in this presentation, and then provide you some information about our wonderful panelists who will be speaking about where the BAS world is currently and some of the known limitations, what is available today to move the industry forward into a more easily integrated cloud-based IoT platform, and then finally, how that can be taken into merging building asset and predictive energy management systems. Ingenuity Systems has been creating BAS, BMS, and OEM solutions for 25 years, and of those 25 years, we've been designing and distributing Echelon and Adesto parts into solutions for 20 of them. Ingenuity has been at the forefront of the IoT movement, installing over 4,000 cloud-based control applications since 2006. And the very first one that we did was based on a ILON smart server from Echelon. From Lawnmark, we have Ron Bernstein, who is the CEO and principal engineer at RBCG Consulting. He has over 30 years of experience in industrial, commercial, and residential automation controls and communications technologies and markets. Mr. Bernstein is a published author, frequent columnist, a lecturer, and advocate for open integrated control systems. He has a BS in mechanical engineering from Carnegie Mellon University, a master's in applied psychology from USM, and a master's in philosophy from PTS, and of course, he's a certified Lawnmark professional. From Adesto, we have Rich Blumseth. He's Adesto's product management director for IoT products and been on the board for Lawnmark for many years. Since 1989, he's worked with hundreds of OEM manufacturers, integrators, end users, and specifying engineers on the development of networked control systems and products within lawn technology. Rich has been instrumental in creating more than 300 Echelon products for the open control networking market that Echelon created, including the Smart Server IoT, something that we're going to touch on today. And from IBM, we have David Blanche. He's currently the product leader for IBM Tririga Building Insights, IBM's cloud platform for facility optimization, and which uses AI and IoT to drive greater operational efficiency for clients in areas such as energy management and space management. He joined IBM in 2010 and has had several roles in IBM's Watson Internet of Things division, including product management, customer support, consulting services, and business operations. David is based in Austin, Texas, and holds a BBA in finance from Texas State University. We are going to be running this webinar for about an hour. We're going to get jumping into it right now with Ron. If you have questions, please type them into the question box, and at the end we're going to leave some time to answer those questions. Take it away, Ron.
Okay, thank you, Mike. I just want to make sure you're seeing my screen. We've done a screen share here. So that
you see
Yep, great. So I thank you for the introduction. I have a brief presentation talking a little bit about the evolution of building automation from more of the design, the architecture, kind of where we were, where we are, and kind of where we're going. So there's a little bit about me. We already saw that. So let's just jump in with sort of the evolution of control systems. Where are we today? So the market is moving to more what we call smart systems. And the evolution of that has been by moving more technology and compute horsepower down to the lower levels of an automation system. So we're getting smarter devices, we're getting devices with advanced capability, even some with pursuing artificial intelligence down at the device level. So they're getting smaller, they're getting cheaper, and more pervasive. And then owners are becoming more savvy as well. They're driving better design through owner requirements rather than just responding to the vendor and supplier market. So we see more capabilities, lower installation time, and a greater need and adoption of what we refer to as interoperability, the ability for things to work better together. So the cost benefit drivers of this are reducing on-site installation time, doing more predefined engineering work, and allowing for what was traditionally we refer to as siloed systems, where like a lighting system or an HVAC system or security system that fully operated on its own with one vendor is now being integrated into a whole building environment and getting better building information and driving value and cost down and value up, both to the supplier and to the end customer. And so what we have are some expectations and level setting that people are looking at, and the industry is responding to this desire for a consistent approach to their controls. So rather than having 4 or 5 or even upwards of 10 different control systems and control architectures in one facility, we're looking at a harmonized view of all that, which means that there needs to be some standards and some interoperability between suppliers that in the past really probably weren't very integrated or even in communication with each other. So we need to improve the system performance, reduce that installation time, and in many cases remove or reduce the proprietary locked-in solutions and develop a more IT and IoT centric environment and leverage an existing infrastructure, which helps with the response to outages and dealing with better integration into things like alarming systems, remote monitoring systems. We'll talk a little bit about the advent of building systems that can link to standard IoT device interfaces like smartphones and tablets and that sort of thing. So the evolution has really followed this kind of model of the ability to take the core data that comes out of control systems, which are really the signals. These are the sensors and actuators within a building that actually do things, and start moving up the food chain a bit to maybe share that data in a historical way, maybe collect that data in real time so that we can maybe process that data with some information and contextual information about location, about time, about duration, and provide some ability to analyze that information and then start making some important decisions for such things such as preventative maintenance, analytics reporting, to do other higher level functions that provided the system operator and the owner with greater level of knowledge. And taking that one step further, if we're able to validate and predict over time and then take corrective action in control, we start getting into the intelligence or even into the artificial intelligence world. So we're moving across these key performance indicators by taking the low-level signals all the way up through advanced applications. And sort of tee this up for the IBM Watson group a little bit, is that you've got to start with good data. And it all starts down at that control system and some consistency of this data to be able to do something with it. And this is really where we shine. We developed some core technologies and interoperability from Landmark. And again, Landmark is a nonprofit trade association that works at this level to take that core data and bring it up into this information and be able to present it in a common way across many different platforms. So one of the models that we use is this, what we call a 4-tier architecture. And the idea here is that we identify our tier 1 enterprise system, our tier 2 building level network, tier 3 subsystem equipment, and tier 4 field sensors and actuators into a model that allows for greater adoption and this clear roles of responsibilities and who's going to do what and how to present data and how to integrate across different systems. It establishes a common control and communication requirements and allows for, up at the enterprise level, a common set of data services that can be provided. This is something that ASHRAE has adopted. ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and has used this in their guide specification to delineate how to define a project and how to scope that project. So part of it is really the interactions between the different entities. And these could be from equipment suppliers to system integrators and master integrators to API suppliers up at that enterprise level. And when we look at an architecture, and forgive the detail here, but it's probably important to realize that the end devices are becoming smarter that can take that tier 4 information and dump it right into an IoT platform where we can put those end devices and control networking devices into this sort of centralized data environment where then we can get access to it from these remote applications. We can have an IoT platform that has a common and consistent way of accessing not only one building, but as Mike was saying, across platforms for hundreds or even thousands of buildings. This repeatable model makes it very, very conducive to having a good support system underneath of it so that we can develop common user interfaces and common dashboards based upon a common set of standards. So this is sort of the approach that we're looking at. It provides a structure for good contracting where each one of these different tiers could potentially be a separate contract to a different entity. We can get bid at each level in a separate contract, clear roles and responsibilities, improve that competitive bidding, especially in public sector work. We're seeing the need for competitive bidding and reduction of sole source supply. So it improves that integration and allows for better system interoperability and open systems. And it also helps the specifiers for these projects develop a foundation for their requirements. Helps the engineering community. So when we start talking about these enterprise level systems, there are many of them. Here's some examples. The EEMS, which is an enterprise energy management system. Many of the advances in the current state of the industry have been driven by energy management across multiple disciplines, from lighting systems to HVAC systems, refrigeration, and other high energy consumption systems, has a requirement for that cross discipline. And then energy information and modeling systems. This is even before it gets into the building. How do you model that? How do you take building information modeling, or BIM, and bring that into a real-time system? And then there's the industrial control systems that kind of bridge the building control systems for things like process control and the old familiar SCADA, supervisory control and data acquisition. So there are just quite a few different types of systems that all need these kind of enabler technologies. And owners are looking to capitalize on their investments and make sure that we don't lock out innovation, but the interfaces to the various systems are well defined and optimized, and in many cases helping reduce the environment for maintenance and truck rolls and support costs and that sort of thing, and also to provide visibility. How are we doing? What are the reports that are needed from an energy standpoint, from an operations standpoint, from a risk and mitigation standpoint? and also looking at mining information beyond just basic operations, which poses some challenges and maybe some opportunities that in today's market, there really are no common standards for the APIs, like kind of what IBM is doing, and in some cases what Adesto is doing. There are no standards for that. Everybody's kind of doing their own thing. And in the world of IoT, that customization has a high cost that goes with it. So there's a need for this cross-platform, multi-protocol web services standard. So in the kind of the objectives in the industry is getting that greater access to systems, providing better enhancements and lower costs, and improving the life cycle. And I think, hold on this one for a minute, I think in my world, most of the clients we work with are looking to extend the life of their installed legacy systems, and how can they extract information without having to go back to the drawing board and replace, rip and replace those systems, and how can we extend that through easier adds, moves, and changes, and scale to size. And also working with the vendors and suppliers to get greater choices, as I said, going to that legacy system and upgrade process. And so in the world of retrofits, and looking at the options, there's a model that ASHRAE has adopted in their guide spec, which helped pioneer, which is looking at it from an upgrade path. If we have an existing system and working with a supplier, how could we upgrade what's already there into something that will work for the future? And that might be a software or programming upgrade, or it could be taking a controller and modifying a controller but leaving the equipment as it is. Maybe integrating, if you can't upgrade, we look at potentially a third-party gateway or interface, or what we'll be discussing a little bit later is maybe a web services interface or an edge server that can extract information from the existing equipment without actually upgrading or touching that equipment, and providing greater access into the higher level enterprise applications. And then, sort of the one that we all don't want to do is sort of the rip and replace, where key components just have no upgrade or no integration path and are high risk that they do have to go through that process. And the last one is always the one most people do, which is defer. So we're just going to let it go and keep it as it is until it actually breaks. So identifying the non-critical, low-risk components that can just keep going as they are. So I believe, and I think we'll talk about today, that there's significant opportunity here in this kind of cost-effective opportunity for the integration side. So the driving market changes are happening at the large end users, are driving these needs for better visibility and greater access into existing systems. The suppliers are looking at it from being leaner and more competitive, tier 2 and tier 3 players competing for market share with a portion of the system, which requires more performance and functionality and maybe less bells and whistles. And controls becoming a commodity solution, innovation is happening in this sort of edge level. And then the consulting engineers who are specifying these projects are looking for better standards to help with their specifications to drive owner requirements rather than maybe supplier compliance. So here's a kind of a little bit of an eye chart looking at all the different systems in a building that it may be affected, looking at this tier 4-tier model. And I think the opportunity now is looking at those enterprise applications and how a cloud services model or a web services model might provide interaction between that higher layer. If a tier 3 and tier 4 system already exists, how could we bring a new platform into this sort of enterprise level? And what we're looking at are some of these edge servers and the IoT market trying to enable the new capability, with also keeping in mind the cybersecurity issues with things like backdoor access into buildings, and making sure that we don't run into those access and security issues. defining well-defined access points into the building, managed by the owner, not the vendor. We've all heard stories that there have been backdoor accesses that have corrupted and accessed personal data, reduce those cybersecurity risks, develop some standard web services that I think Rich will talk about in a minute. But I think there's an opportunity that Lawmark is working on to develop a web services standard to address that tier 2 and tier 1 interface. Also developing some standard API interfaces and models that can share a common device profile model at the tier 3 level for standard data sets and fully documented compliance model where we can have a variety of choices out in the marketplace. And I think, as my last piece of this in the marketplace, it's time to sing a new song. I'm more of a classic rocker guy, so we've looked at clouds and said, hey, maybe there's some new opportunities to go through the cloud and get a little bit more clarity. And yeah, if you're a Yes fan, close to the edge server, that's really where we need to be. That's where the market is headed, and enabling those best of your favorite IoT things. So I'll just leave it at that. I think we're going to take questions at the end, and I'll turn it back over to Mike.
Thanks, Ron. Yep, that's right. We are going to be taking questions at the end. We've got a few coming in. I'm trying to answer them on the chat. I'm handing it over to Rich with Adesto, and he's going to take it away now. Go ahead, Rich.
Okay. Good morning. Can you see my screen okay?
Yep, looks great.
All right, great, thanks. Yeah, so I'll follow on for what Ron was talking about and describe how edge servers can help bridge that gap that he was describing that we have between sort of today's systems and the promised IoT future. So first, a little bit about Adesto Technologies. Many of you probably know us as Echelon. Echelon was acquired by Adesto Technologies last year. Adesto is the leading provider of application-specific semiconductors and embedded systems for the IoT era, so it's actually a great fit for Echelon's technology to combine with other technologies within Adesto. And our customers can then embed the innovative technologies that we have into their solutions and really get seamless access to data and control in this new connected world. Right, so Adesto was founded in 2006. They've been supplying for a long time to tier 1 OEMs, especially flash memory components. But Adesto is very focused on high growth IoT markets, which Echelon also was. So it's a very complementary combination between us, and we have over 5,000 diversified customers. And we're offering products at all the tiers that Ron talked about. So at the edge tier, things like memories and ASICs and transceivers and controllers. In the middle tiers, the gateways that kind of combine the other tiers together. And then in the cloud software for communicating with these various systems. We're primarily focused on the industrial market, not the consumer market. So IoT is really changing the facilities industrial systems markets. You know, if we look at the traditional markets for building automation and control, the kinds of things that were done were commissioning, auditing, some local control, energy management, preventative maintenance, and automation. But now with smart buildings and the promise of IoT, you know, we find that, you know, building owners and integrators and facility managers want to do much more, right? They don't only want to commission an audit. They really want to share data across the enterprise. They want to be able to have both local control as well as cloud management. They want to do more than just manage energy. They want to optimize the utilization of energy. And not just prevent maintenance, but also do predictive maintenance. You know, replace devices before they fail to reduce the cost of operation of a system. And not just simple automation, but really personalized automation that can provide a more customized user experience for each user. And so if you look at the size of the different markets, in blue you see sort of the traditional building automation and control market size and the revenue potentials. But if we can move beyond that into smart buildings and do some of the other functions, the market sizes are much bigger. And you can see the growth from 2017 to 2022 shown here, where that growth is coming from that evolution into smart buildings. But what are the challenges in accessing these industrial systems? What's preventing us from making that move? So first are the many protocols that are out there in use today. So protocols like BACnet and Modbus and LAN and CAN and many others you see there on the left. It's a huge number of protocols. You kind of see over time when they were introduced, and moving to the right, more and more are being introduced. And so the challenge is, how do we integrate all these things together? And the promise of IoT, if you look at many IoT devices, especially in the commercial and the home space, home control, often those IoT devices are wireless, and wireless is great for many kinds of systems, especially home systems. But what surveys have found, such as this one from 2017 IHS survey, that most industrial control systems are still wired, right? And wired and non-IP connected, right? So we have IP connected wireless devices, kind of in blue, but non-IP connected, often wired devices in orange. And that's what creates a challenge, right? Because things are easier to connect together when they're IP, but when you still have a large percentage of non-IP based devices, how do you make them all communicate? And these problems are made worse by the state of today's building and automation and control systems. This chart on the left is similar to what Ron showed. He had a 4-tier architecture. This is 3-tier, combining the 2 middle tiers. But the state of the system is a little different today than from what Ron showed, because Ron showed sort of at top level, workstations being able to talk to everything within the system. And in many systems, that's just not the way they're built today. There's a desire to get there, but the way they're built today is there's often these silos of automation, right? That you can draw sort of a silo vertically through each of these tiers, and so that the top tier can reach the bottom tier for its silo, but it can't reach the bottom tier for the other silos. And that's because of a lack of interoperability between those networks, between the protocols, and even between the vendors using the same protocol. And there's also very limited choices in terms of media types and applications. The hierarchical management is closed because of these silos, right? So that, within a silo, you can manage all the way down to the edge device, but you can't manage other devices in other silos. And as Ron mentioned also, there's been some major security breaches in industrial building automation and control systems, and those have reached the press and have really got a lot of building owners and facility managers concerned about the security of their systems. And that's because they were relying on these sort of legacy security protocols that weren't as secure. So we believe that the solution to these problems is threefold. First, and as Ron mentioned, interoperability is absolutely key. We need open standard networking and open standard data abstraction. It's not enough to be able to pass a piece of data from one system to another if that other system doesn't understand what the data is or what it means. And so, Lawmark has been doing great work over the years to really standardize LAN networking and standardize LAN data abstraction. But we need to take that beyond LAN into these other systems. The second fold, an edge server can provide you with mission critical execution. There's things that just need to happen in real time, things like real-time control. So for example, response to an over temperature alarm or response to a motion detection. Those things need to happen quickly and can't really afford a round trip to a cloud and back to have something occur locally, especially if cloud communication sometimes goes up and down. And we also need peer-to-peer communication, right? That's what provides the real-time control, so that if that motion sensor can talk directly to the VAV controller that needs to know that the set point has changed very quickly, that can happen with a peer-to-peer connection and not have to have a round-trip delay. And finally, the edge workflow. We want to separate the cloud and edge workflows so that, you know, the large amount of data collection that can be done in a traditional IoT system where you have lots and lots of sensors collecting lots of data, you can filter that data out, collect a lot of it locally, but then selectively forward it to the cloud, so the cloud has key information but is not overwhelmed with terabytes of data. So Adesto has introduced the Smart Server IoT to, you know, bridge these building automation control systems to the IoT. In the top left, you sort of see the architecture of the Smart Server IoT. It's built on top, well, below, a common set of web services APIs. As Ron mentioned, you know, these APIs are really critical to solving the interoperability problems and the connectivity problems from the edge to the cloud. Serving up those APIs are edge services within the platform, and those edge services are built on top of a common data model and the capability of creating connections between data points. And so we can support that you know, peer-to-peer communication at the edge. And then finally, that's built on top of protocol engines that can talk to the protocols that are out there. Because yeah, we know that users don't want to rip and replace their devices. They want to keep using the devices they have, whether they're LAN devices or Modbus devices or BACnet devices. They'll be out there. And so the way to support that is with protocol engines for each of those protocols that are commonly used within BACS systems, and make that data available to the rest of the edge server and through the APIs to any cloud and enterprise services. The hardware looks like the bottom left. You see the far bottom left is the Smart Server IoT, and then there's some expansion modules for it, IO expansion, as well as expansion to talk to different LAN media, such as FT or TP1250. So the combined platform on the left then provides the services on the right, secure IoT messaging to cloud services through the standardized web services APIs, edge device and data management services to actually manage, for example, LAN devices in the system or interface with Modbus devices or BACnet devices, provide full connectivity and network management, be compatible with existing open installation tools such as LANmaker or the ISOC commissioning tool. Do that with built-in protocols, like I said, the key protocols, but support extensibility so that additional protocols can be added in the future and additional applications can be added either by OEMs or integrators, all with open APIs and open interfaces to talk to IoT devices and protocols. Built into the Smart Server IoT is an integrated central management system that really streamlines your field operations from any client with the browser. So it's all browser-based. The web server is actually built into the Smart Server IoT and presents an interface like you see in the top left there. So it's a simple kind of widget-based interface where the integrator user can see the devices in the network, can see the types of devices, whether they're Modbus or LAN, see them either on a map or on a floor plan for a building interior, and actually then be able to set up the system and get it operational. So the built-in central management system provides device provisioning and management. It supports data logging and retrieving, so you can log selected data and then retrieve it back through trend graphs. Supports monitoring alarms, so you can configure alarms that will set based on, or be set off based on exceeding alarm limits, and create peer-to-peer connections between devices. And we believe the Smart Server IoT is the industry's only really open and end-to-end solution. You know, we kind of characterize edge servers in general along two axes. One on the left is openness. You know, how open are the APIs? How open are they to anyone creating an application, either that runs within the edge server or communicates with the edge server? And If you look at within the openness spectrum, the top left are things like IT gateways and SCADA systems, single board computers. They often tend to be quite open. You can extend them very well. And the Smart Server IoT is also open, so full open APIs, and anyone can create applications for it and integrate with it. But the other dimension is at the bottom, the end-to-end. And what end-to-end means is really being able to go all the way from a cloud, say within a cloud, I want to install a device, and that device is on some edge, some edge device, some edge protocol. And do I have to invent any software to do that, or do I have to invent any user interfaces to do that? So end-to-end means all the pieces are in place to support that. And those open systems in the top left, they tend to not have all the capability of managing devices at the edge, right? You can add it because it's open, but it's a lot of development work. And the bottom right are the more traditional building management, automation, and control solutions and AMI systems that tend to be vendor specific, right? So they tend to be very good end-to-end in terms of having, workstations and software that can interact with the vendor's devices and manage the devices and set up the networks. They do a good job of that. But they tend to do that in a very closed way, providing the vendor lock-in so the vendor can only sell their products, or their customers go and buy their products to extend their systems. And so we believe we're sort of in a sweet spot with the Smart Server IoT, where we have the openness of the top left systems, but we have the end-to-end solution of the bottom right systems. And so that allows then the customer needs on the right to be supported, and the workflows in the bottom right to also be supported, all with a single platform that's both open and end-to-end. So the key takeaways for what I've talked about today are, first, the IoT use cases really need to break the silos that are in today's industrial systems. So the vertical bars on the left side are sort of the silos you often see, whether there's access control or HVAC or room controls. Each one of those, there tends to be software and hardware products within those vertical silos, but they don't tend to go across. Whereas if you look at the horizontal bars, that's where the IoT use cases, things like preventive maintenance and energy optimization, personalization, those need to go across the silos, right? And that's what the IoT use cases are. So we have IoT going across, we have industrial systems being those vertical silos. And we believe that open edge servers like the Smart Server IoT are going to be the bridge between the industrial systems provided in the vertical bars to the IoT and cloud services identified in the horizontal bars. And I believe that's it. Yes, that's it. So back to you, Mike.
Great, thanks, Rich. I did have one question that came in that I thought maybe would be best if we touched on it now. There was some data that you were talking about, comparison from 2017 to 2020. And there was some questions about what region that was in, what market it is in, and what was the source of that data. I think you mentioned it, but if you have it off the top of your head, or you can jump back to it, that'd be great.
I think that was this one here, right?
Yeah, I believe that was it.
Yeah, so that was from IHS. I believe it was an international study, but I don't have the details of it handy. I can look that out, and maybe we can send that out in an email follow-up as to what it referred to exactly.
Yeah, that'd be perfect. All right, I'm going to be turning it over to David from IBM. We really appreciate the time and information, Rich. Did a great job.
Thanks.
Go ahead, David. Take it away.
Brilliant. Let me just move into slideshow. Just verify you can see my screen.
You're good to go.
Fabulous. Okay, thank you, team, and really do thanks for this opportunity. You guys might be wondering what IBM is doing, especially somebody from the Watson IoT group is doing, speaking to a group of mechanical engineers and industrial control experts. So the purpose of this next phase, let's say, of the discussion is to show what this trend and opportunity has become given the push towards unleashing the data and having opportunities to integrate it with existing systems. But I want to start by introducing kind of who we are in IBM, specifically in the Internet of Things group, to just set the tone and context for how we approach this what we see as a very great opportunity for us. We have a portfolio of solutions in very asset-intensive industries in the IoT group of IBM Watson that's really tailored around three main portfolio segments. So let me just briefly touch on them. IBM Maximo for enterprise asset management, where clients do maintenance, where the system of record and the maintenance history data lives. IBM Tririga, if you take it up a level from the buildings and facilities beyond just traditional asset management to how I manage the life cycle of a building. When I commission a new building, when I do capital projects and planning, how I manage the lease of that building and all of my facilities, how I manage the assets, how I manage the space, how I manage the energy. IBM Tririga provides solutions tailored towards what we call an integrated workplace management system. We also have a portfolio, and I won't talk too much about this today, around engineering. So as the team was talking earlier about the compute power of devices and these connected things, millions of lines of code are being written to run on the devices, and it provides a great opportunity for us to use that data stream as a feedback mechanism to design better products and move towards a more agile, kind of software-driven device lifecycle. And then, of course, IBM within our IoT group has our IoT platform, which is really the glue and the connectivity layer, which gets the data in a data lake almost to an extent that we can unleash, the power of Watson and AI and advanced analytics. Our clients span every industry. We work with some of the biggest names out there. You guys can read the charts here, but within the Watson IoT group, 7 of the 10 largest automotive companies, 9 of the 15 busiest airports, 8 of the 10 top Fortune 500 companies, et cetera, et cetera. These clients all know assets. They have very specific industry challenges, industry problems, and they turn to the solutions in the portfolio that I showed earlier to help address those. And one trend that we've seen in IBM, of course, and it kind of echoes what we've seen with this presentation today, is really about the proliferation of IoT and the increasing trend towards connectivity. Whether that's clients getting started and augmenting their maintenance with condition-based maintenance, and the ability to move into preventative or predictive maintenance, et cetera. This trend of where the industry has gone and towards open connectivity has really allowed our clients to adopt IoT in new ways. But if we look at the building segment and where building management has come, I certainly don't have the expertise, especially the prowess, so to speak, and the experience with these control systems. But I think all these points have been echoed here today. The few things I want to touch on that really allowed for somebody like IBM to come at this is the push towards adopting these interoperable protocols. And making the data and getting it out of systems, proprietary systems where the data is stuck in silos. This kind of pushed and allowed this trend where clients started moving towards this era of smart buildings. It allowed interoperability to work. It allowed to aggregate performance and gauge performance and across an entire enterprise, not just a specific building. And really this trend creates an opportunity for us, because what it does, especially for us in IBM, we're IT experts, we're not so much OT experts, but it allows the data to be unlocked and take advantage of what the IT has to offer. So if you think about the IoT, the traditional challenge in IoT is that we have billions of different sensors we have loads and massive amounts of data, but in order for us to make sense of it, we have to structure that data in a way so that we can run and process these analytical workflows. And to the extent that we're processing those workflows, many of which will exist on the edge, and the team talked about the edge compute power and where the trend of going with technologies are going with that, like with the smart server. And then there's some of this compute power that it makes sense to run it on the cloud. And so this is the opportunity that we see, and why the future and where you see IBM making investments is around AI. And this is really where the Watson angle comes in. So you see a quote from our chairman and our CEO, Ginny Rometty, talking about the change and the impact that AI is going to have. It's covering 100% of jobs, industries, professions. It's not a technology issue. It's not a change management issue. It's changing how people do their work to add and augment and help the way that we do our work. And so if we think about how AI works and just the core kind of fundamental elements of it, any AI system has the ability to provide reason and insights and actions. The AI system, which is trained with data, has confidence in the decisions that it's making. By definition, these are also learning systems. So as time goes on, the system it's not a computer system that will just do let's say a rule or logic and just compute a formula. But as it sees the patterns and the trends, it's changing how it reasons and how it scores and what decisions it's going to recommend. And the last common element is that these AI systems have to be natural and human interaction. Because we're augmenting how we do our jobs, they have to be easily accessible. They have to be consumable, and it can't be strings and lines of code. So we believe in IBM, and this is where you'll see the trend, and I'll talk a bit about what we're doing in this space. We believe in the next generation of smart buildings, really leveraging this hybrid world where you can have compute power on the edge to facilitate several use cases and bring value. And then there's some data points that can be moved up to the cloud and leverage advanced analytics and AI capabilities like Watson and others. So this allows for behavior that's learned. You're able to do predictive scenarios. You're able to tie data together from external sources and environmental factors, whether that's weather, whether that's the meeting room schedule for the rooms, the conference rooms in my facilities, whether that's the sentiment or a feedback mechanism from the individuals or the employees in my facilities. This is the power of sort of the cognitive era, which is bringing this data together and finding new insights and prescribing new actions that could be leveraged. So in our clients, the ones that I mentioned earlier, especially when we look at the power and the opportunity that IoT and AI presents, these are the four main themes that you'll see and where IBM is investing. We have solutions in the market today, and we'll continue investing in these areas. Energy optimization and sustainability has been talked about by, I think, by every group here, and for very good reason. You know, IBM commissioned this study with one of the leading analysts, and we asked clients where they saw greater efficiencies could be had in IoT. And the top two area, even though these energy management solutions have been around for many years, was still, I believe I can get more out and reduce my energy expenses. Whether that's for a competitive advantage, if you're in a retail industry, or to keep your costs down, or whether that's because you're operating a commercial building and there's opportunities to be had. Predictive maintenance, if you think about Maximo and where clients are maintaining their equipment, what IoT data, what equipment, what asset data can do to give insights to how you're maintaining that. Understanding the people trends and the usage of the space inside the facilities and inside the buildings, taking that and better optimizing your real estate footprint and your space. And then we'll talk about this in just a little bit, but where all of this is leading is down to the individual, down to the employee, because the cost to any organization, the greatest cost, especially those operating, let's say, a commercial building or office building, is the cost of the employee and the talent retention. And so there's a lot of work and a lot of research out there that suggests and that shows the correlation between productivity and engagement levels and what the building and environmental factors can have on those. One example here is a product we have called Tririga Building Insights that's focused around energy savings, and it's doing it from an IoT and an AI lens, where once you get the data up into the cloud and you create and you map the data to all of these various systems and you leverage technologies like the Smart Server IoT, you're able to baseline that data with various operation points or weather company data, and then we run several AI capabilities, whether it's anomaly detection to spot potential failures, or whether it's predictions that are using forecast data from the weather company, and then we're able to identify which assets in my enterprise are wasting energy for me to take action and ultimately lower my energy footprint and achieve my sustainability goals. This goes a level further if you're able to add environmental and occupant data to that. So I talked a bit about that environmental data. If I take the energy consumption, let's say in an HVAC setting for my air handling units, and if I look at the zones in a building and I infer occupancy levels, let's say using CO2, I take the energy rate schedule for how maybe I have a time of use rate schedule for this particular building. I bring in the real-time weather data, the forecast data, and I look at the bounds that I allow my tenants to alter and modify the temperature. I'm actually able to prescribe set point settings back to the BMS systems for how to optimally run and operate my equipment. So in this case, I mentioned this earlier, this is an HVAC pre-cooling scenario. So in the bottom right-hand chart, you'll see that this particular building was on a schedule to cool the building to 25 degrees Celsius starting at 7 a.m. And obviously the goal is to get to move the set points to this and maintain it for when I have people in the building. But this AI system actually found that it was far more efficient to start gradually cooling the building starting at 5 a.m. And you'll see this in this green temperature line graph, the gradual cooling and the impact it had on reduced power draw from this piece of equipment. So you'll see a 30% reduction in the power draw for just operating it more efficiently, taking these other data points into consideration. Asset performance management, we talked about predictive maintenance, reducing failures, reducing maintenance costs, and improving the asset utilization. IBM Maximo has solutions that allow that, again, based on AI capabilities. We have solutions that we team with our IBM services group to take, and I don't know how this video is coming through, but technologies like augmented reality to enable the maintenance worker to more efficiently perform their jobs. And again, the push here is towards productivity and push towards the employee comfort and employee well-being, because again, this is where you can achieve, clients can achieve the greatest level of ROI. And so air quality, noise, temperature, how that all affects the individual, offering those things into a seamless interface back to the employees in a way that they can interact with their space, interact with the buildings, and then integrate that with systems so that the employee can also identify where their work colleagues are, maybe on a particular floor, or take that data and then look at what rooms are currently vacant and then book a meeting room or free up meeting rooms based on the occupancy status, even if it might have been booked. These are the trends that we've worked with and you'll see continuing investment out of the IBM Watson IoT group. And it really just all comes back to where we started this discussion, back into the operational foundation, the compute capabilities that we have on the edge to bring that data up into the cloud. And then in cases like the optimization scenario, to bring those set points back of maybe what an AI system might have prescribed. And it's why IBM is teaming and has partnered with Adesto to do this, and where we see huge potential and taking advantage of what the smart server IoT has to offer. So just to leave everybody with a provocative thought, or to challenge you, based on these AI capabilities and based on facilities in your own client settings or the buildings that you manage, how are you going to put smart to work? So Mike, I'll turn it back to you, and I think we might have a few minutes for some questions.
Thanks, David. I do have a couple of questions here. We got a question, I think it was from when Ron was talking. It was about access points. What is an access point? What's a secured access point? Is that talking about Wi-Fi or gateways of some sort? Could you shed some light on that, Ron, and just talk us through that?
Yeah, so I think that was in regards to how we're onboarding these new, not only field devices and equipment devices, but also the edge servers. There are many ways of accessing information. I think Rich talked about Wi-Fi, there's Bluetooth, there's Zigbee. Some of those are more palatable in the commercial world than others, especially in very well-controlled environments like hospitals or military facilities, where these access points have to go through a very specific onboarding procedure in order to not violate privacy data and other potential hackers from getting into the facility. So those access points have to be relatively well-defined and go through a hardening test depending upon the requirements of the facility. Too many of the controls there were in the what we call the Wild West days, where say, hey, we'll put our controller in, we'll put it on a BACnet or a LawnWorks network, and oh, by the way, we don't tell anybody, but we have our own 3G, 4G backdoor GPRS modem that we get into that controller to do our work as a supplier, and we don't necessarily tell the end user that it's there. Those things are those very, very concerning access points into the system. I think that's what the question was referring to.
Yeah, I think that has answered it. If not, Chad, go ahead and just shoot another question, and we'll see if we can address it offline. I've got a question for Rich here. Excuse me. It says you've talked about the new features of the smart server. So what are the development tools to design trends, alarms, reports, put data points onto floor plan maps, etc.? Could you shed a little light on that for us, Rich?
Yeah, absolutely. As I mentioned, one of our key pillars of the design of the smart server is to make it open from kind of top to bottom. A big part of doing that is to base it on top of an open operating system, which is Linux, and use fully open development tools for Linux. There's many open source development tools, as well as open protocols. And so, we're working with Landmark to define a standard web services API. That API is built on top of two IoT standards, which are MQTT and REST. And it turns out, since they are open standards, the development tools available for Linux have great support for them. So there's actually no particular language that's required to be used, as long as you have a language that has a compiler. If you want to run on the platform, a compiler for Linux, or if you want to run on some other platform, a compiler for that platform, and that language and runtime supports either MQTT or REST, then you can develop applications for the smart server. So no special tools are required at all. You can do all the development work with even free open source tools for Linux, like Visual Studio Code or others that support a language and runtime that support MQTT or REST. So we've really made the cost of development much lower, since no costly development tools are required.
Okay. We're up against time here, but we got a couple more questions that I hope we can answer. So, what do we think that the benefits or advantages are of edge computing compared to existing Niagara framework and analytics?
Who's the question
maybe
for?
I can take a stab at that one. So the model, I think that comparatively to the Tritium Niagara model, they've done an excellent job at identifying the market needs and have come out with a pretty good platform. However, that platform does have some limitations in the global adoption, and I think what Rich was talking about, the open source platform, licensing issues. I think the market is looking for taking that idea and bringing it more to a more open interoperability model and using more up-to-date web services criteria like the MQTT and REST model, and allowing API developers to have a community to develop that without having a single entity having controlling interest in it. I think, Rich, that's kind of what you were alluding to with the community forum and the Open Linux platform, if I'm not mistaken.
Yeah, absolutely. That's the big difference that we see from the approach we're taking with the Smart Server versus the Tritium J's. They have a very rich set of APIs that do support the needs of the applications, but they keep the APIs, the good ones, pretty closed, that they have a small open set. And we believe it's very important to keep it all open so that anyone can do development without, costly licenses and royalties and keys and that sort of thing.
Yeah, and I just would add one piece of that. I would, we've worked very closely with Honeywell and Tritium in the past. It'd be great if those folks would be willing to come to the table to some of the standards bodies and say, hey, let's take the best of both worlds and build an open standard for the industry such that there could be greater innovation. So it's sort of an open invitation to say, hey, let's take the best of both worlds and work towards an adoption plan.
Yeah, absolutely. That would be great.
Great. Thanks, guys. One more here, and I think that this will be a pretty quick answer since it's about the Open API. But somebody just wants to verify or find out if there's any special requirements for the cloud provider for you to be able to talk to the Edge Smart Server. Rich, just want to hit that one real quick.
Yeah, absolutely. So, many of the different systems that we work with, like IBM Watson, you have different APIs. But as long as they're open, then it's easy then to create connectors between the two. So what we've done is we've been working closely with IBM and integrating the Smart Server with IBM Watson and their cloud services. And the way we do it is we just create a small connector application that speaks the web services API on the Smart Server, and then also knows the web services API that IBM Watson provides. And since the two APIs are open, it's very easy to connect the two. And so that's how we get the connectivity.
And Mike, if I could just add to that, part of the objective here, and one of the reasons Adesto came to Landmark and said, hey, we'd like to develop this web services Internet Access Protocol, or IoT Access Protocol, the IP, into a standard in a web services world, is to make sure that it does have industry consensus and there's lots of people involved in it. So we now have a new working group both within Landmark and within ANSI CTA, as well as a new work item within the CEN European Standards Group to develop this model with industry consensus. So Adesto is taking the lead on it, but I would highly encourage anyone interested to get involved in this, learn about the API interfaces, the calls, the structure through the Landmark Working Group. And it doesn't necessarily need to be a LAN device. It could certainly be a BACnet or any other protocol. It's up at a higher level. But we've got a nice platform for doing that. We've got some nice work items already in process. We anticipate that this will become a national standard and potentially an international standard through the work over the next couple of years.
Yeah, and I know that when Ingenuity developed our open API and our cloud platform, it can be hosted anywhere. We can integrate with the Smart Server IoT or a Jace or anything else. So about getting that data out to the cloud, that's what's really important. And the Smart Server IoT just makes it that much easier, and they're partnering with Watson. We've got some suggestions for additional webinars to do in the future. People really want to see the new Smart Server in action, so I think that we'll work with Aperba and Rich to get something on the books for that and start sending it out. But for today, that is our time. If anybody has additional questions, you can email me and I will coordinate with our panelists here. My email is Mike, M-I-K-E, @engenuity.com, and that's spelled ENGENUITY.com. I want to thank everybody for attending, thank our panelists for all of the great information that they shared and taking this time to really educate us. Again, if you have additional questions, reach out to me, and I'll make sure we get them answered for you, okay? That's going to be it. Thank you, everybody. Have a great day, okay?
Thanks, Mike.
Bye.
Appreciate it.
Thanks, Mike.